We assume that you are broadly familiar with blockchain as a technology, so we won't cover it in great depth, but practice makes perfect, so let's start from the beginning. The first question is, what is a blockchain? Basically, it's just a data structure with specific rules. A number of transactions are combined into a block. Each block has a unique hash identifier, which is obtained from hashes of all transactions, usually in the format of a Merkle tree, and a hash tree of the previous block. This sequence or chain of blocks is a blockchain. This unique data structure makes the blockchain immutable and protects it from mutations or malicious changes. If something is changed in block A, all subsequent blocks will be invalid and must be created again. As we can see, rewriting history is computationally expensive for data structures like a blockchain, which is perfect for cases where we need immutability. The next question is, what is a transaction? The simplest explanation of a transaction is that it is an event. You can say that each transaction is an event with some metadata. A transaction in a blockchain is a new record with some required and optional fields. Each new record changes the state of the blockchain. This may be reversible or irreversible depending on the stage of the transaction, block validation status, and infrastructure conditions. Well, to move on and to be more concrete, we have to talk about a specific blockchain. There are hundreds of blockchains in use, and all of them have different advantages and problems. Some of them are very well known, like Bitcoin or Ethereum. Some of them are pretty new and relatively unknown. Some of them are very secure and robust, while others are rather weak in terms of security. In this course, we will use the Waves blockchain because it is well known, robust with more than 3 years in production, secure, there have been no serious security breaches, and decentralized. The Waves project started in 2016 by Alexander Ivanov, and over the last 3 years has launched many products we will use in this course. So the Waves blockchain supports many different types of transactions at a core level. For example, an asset transfer transaction contains a timestamp, block number, sender, recipient, amount, and transaction fee. Okay, I hope I've explained enough about blockchain, about blocks and transactions. Now, let's talk about more interesting stuff. Let's imagine that we have hundreds and thousands of copies of this data distributed on different computers across many different countries and continents. Now, to change the block history, we have to rewrite the blocks on a majority of these copies. So it becomes even more expensive process in terms of required computational resources. And again, this is good because our main goal is immutability. That is why you might have heard that blockchain is able to ensure data is immutable for a long time. The problem is that different machines are able to generate different chains of blocks, either deliberately or by accident. So the different copies of the blockchain they hold may not be the same. This phenomenon is called a fork. To keep exactly the same data across different machines, all participants have to reach a consensus for each new block. The network participants must agree on who is responsible for the generation of a new block and whether that block is valid. The participant who created the block is called a block miner, block generator, or block producer. The block generation process is called mining. There are actually many types of consensus algorithms with different advantages and disadvantages. Let's start with the first classical consensus algorithm, which is a proof of work. It was originally designed by Adam Back for an email service project called Hashcash. Hashcash is a proof-of-work system used to limit email spam and denial-of-service attacks. It is based on the computation of a specific nonce value, from which is produced a hash result with a specific number of leading zeros. In a proof-of-work system, all node participants perform the same random calculations in order to find the right value. For example, in blockchain, they repeat it almost every 10 minutes. The probability of finding this value depends on the total computational power. It's a pretty expensive consensus algorithm and not efficient in terms of scalability and speed. In 2008, an author with the pseudonym Satoshi Nakamoto proposed using such a proof-of-work algorithm for a new digital currency called Bitcoin. You can find a link to the Bitcoin paper in the description of the video. Currently, one of the most popular consensus algorithms is delegated proof-of-stake, where all cryptocurrency holders vote for their delegates. Delegates are responsible for validating transactions, creating new blocks, and maintaining a network. The best analogy for this is the United States presidential elections. Delegates are elected by token holders through a delegated proof-of-stake consensus mechanism. The number of delegates is limited to a predefined and relatively small number. The only selected participants are able to generate new blocks in a predefined order. No one else can participate in the block creation process. There are a lot of questions around whether this should be considered as a real decentralization. The Waves blockchain uses least proof-of-stake consensus algorithm instead. Rather than selecting a limited number of block producers, LPOS users are able to lease, not transfer, just lease an amount of tokens to nodes they like or trust. The probability of being a block validator is proportional to the total amount of tokens leased to that account. Leased waves are locked in the user's account and cannot be transferred or traded. Still, the tokens remain in the full control of the account holder, and leases can be cancelled at any time. Let's get back to the DPoS. But in the DPoS and LPoS consensus systems, node owners typically work on a popularization and user attraction by providing social media activities or developing products useful for the community. Great. But we have a blockchain, we have many nodes. How to work with the blockchain? How to get some data, for example? To work with a blockchain network, developers need to have a test version of it, of course. Waves has 3 types of public networks which developers can use: StageNet, Testnet, and Mainnet. Mainnet is obviously the production network. This is a blockchain with real value, while Testnet is a network to test your products and dApps in an environment similar to the production environment, but without financial risks during the testing period. StageNet is an experimental network with all the new features, but usually with some bugs as well. Every interaction with the blockchain network has a cost in the native platform token, in Waves. The same thing is true for Testnet and StageNet, but there are faucets available for Testnet and StageNet. Just enter your Testnet or StageNet address, pass the CAPTCHA verification, and you'll receive free tokens to test your apps. Great. Looks like we are done with all this interesting stuff. In this lesson, we talked about the basics of blockchain, about transactions, blocks, consensus mechanisms like proof of work and proof of stake, and delegated and leased versions of proof of stake. I hope you now have a better understanding of some of the basics of blockchain. Any remaining questions you can ask in our Telegram chat. In the next lesson, I'll try to give some more insights into how all these blockchain properties we have discussed affect web services.